Hi everyone, we're going to continue with our PCG Graph series, and in this episode we're going to focus on building a bridge, and we're going to utilize some of the latest nodes in the 1.3 version of the asset. We still have, I can re-enable this here, we still have all the um, graph items that we created before. We have the forest, the path, and everything else. Um, and we're just going to build a bridge around here. I have two supports that I'm going to use for that. We have the bridge start and end. Those are just cubes that have been extended a little bit. And yeah, let's jump right into it. Just a note first that there's easier ways to make a bridge using the PCG graph. Um, However, I'm going to focus on a more complicated method of doing it because it adds quite a lot of flexibility and kind of features that are really nice to have. Um, yeah, okay, so here we go. So we have the two supports. What we need is some sort of a curve first in between that will define where our bridge is. I'm going to select the PCG manager, and to begin with, I'm going to disable the forest so it's not slowing us down. Um, we have quite a lot of graphs bunched up into one, which means that every time we save, all of this logic would be refreshing, and we don't want that. You typically wouldn't have that in a graph. You would have one graph dedicated for a bridge, one for a forest, one for a path. Because this is our demo scene, we've packed everything into the same graph. So I prefer disabling the kind of bigger bits of it. Um, we're gonna do the bridge below here, but let's create a curve first. So I'm gonna select the PCG manager. I'm gonna scroll to the bottom. I'm gonna hit create curve. And now we have this new curve here. And I'm gonna rename this to bridge curve. Okay. And I'm just gonna drag it somewhere in here. It doesn't really matter where. I'm gonna hold shift. So while I have the bridge curve selected, I'll hold shift, click somewhere here in the middle of the first column, and then I'm gonna hold shift again, click in the middle of the second column. All right, now I have my two curve points. As you can see here, I'm gonna collapse these other settings, and you can see here I have this bridge group, and inside the group I have a few properties that I have predefined. I have one for the curve, three floats for a width, height, and then the board sizes. And then I have a material for the rope that we're gonna use. So if I select our PCG manager again, I'm gonna see all the properties exposed here, so I can drag the bridge curve into a property. And we can also take a look at what the material is here. I have a rope material, um, and you can use whatever you want. Obviously, it doesn't have to be rope. It can be steel or anything else. But for my purpose, I'm going to use the rope material. And okay, so now we can start building a graph. I'm going to just expand the graph window a little bit. And we can drag the curve. And then we'll sample it. Okay, and then let's hit the debug. And then we'll see what we get. Okay, we have our sample points. All right. And what we need, because obviously in the middle, if you think about it, in the middle of the bridge, the only thing we'll likely position in the middle of the bridge are the boards. But the actual supports, the ropes that support the bridge, those have to go on each side, right? They're not going to go in the middle. So we can start with the boards as well, just so we make that pretty obvious where the bridge is. And for the boards, I'm just going to reuse, we have our path blocks, which we use for the road, and those are, it's just an object set that has cubes, and it's just a cube object. Nothing fancy. So after we have our points here, we're going to go to instance and points, and we're going to grab our points from the sample curve, plug them into the instance, then use our object set, plug that into the object set here, and let's see what we have. Okay, now we have these cubes. I'm just going to disable the debug here, which don't look anything like boards really. Those are clearly just cubes, so we have to resize them a little bit. Let's go to update transform and plug our game objects here that we get from the instance and points, and we'll scale them. We'll grab one to just verify. So on the x is the width, so let's say 5, and the size we can say like 0.1 for how thick they are, and then how there's forward size, or the width would be the z, which let's say 0.5 for now, and let's see how that looks like. Okay, all right, so that looks more like boards, and we'll leave that as is for now. We just wanted something to kind of represent where we are, and obviously we can add I can select the curve, I can hold shift, and I can add another point here. So obviously this will follow our curve, and this is nothing special. This is the same thing that we had on the road. So we can select this, group this into bridge boards. Whoa. If I can spell this, perfect. Okay, so now what we need to do is get the two supports that actually are running through the boards. So to do that, we'll use some of the new nodes that we have. And the first one is called an offset. It's an offset points node. So we'll get all our points from their sample curve, right? And then we need to offset those to one side. And how much we need to offset them? Well, for now, let's just say like we'll offset them by 2. And we can also say, okay, mirror this on the x, since this is the axis that we need. Okay, and then let's see. Okay, these are 2 new points, the point series. So what we can do here is once we have the points, we can plug this into another new node, which is called sweep. And perhaps you have used this in a similar node in a different 3D product, 3D editing software. So what this will do is we'll take a series of points and generate a mesh that follows that curve. And this is the reason why we don't want to get them together, because you can see what happens. So if we get all of them here and we just plug them into the sweep directly, what you'll get is the zigzag, because the order of the points is not the way we want it, right? Even if we went this way and then back, there would still be a connection at the end, because it'll connect the last point of this series with the first point of the other series. So we want to do that separately. So we want to actually connect the points and then the mirrored point separately. So we'll actually duplicate the sweep, and then we'll get the mirrored and do a separate sweep. Okay, and then by default, these are circle shapes. So the profile is a circle, which is exactly what we need for a rope. And the size is 0.2, which is fine. Now let me just disable the debug here, and we can get our rope material, plug this into the sweep. Okay, and now we have some sort of a rope looking thingy that does not look quite like rope material wise. So the reason for that is our mesh is very long because of how long our bridge is. And we can change the segments here. I think it's fine. The segments are actually how many sides that cylinder has. So if we the circle. So if we reduce that, you see that okay, if we reduce it to 6, for example, you might not actually be able to tell that much. Yeah, you can tell a little bit. This is more square, but um, we'll leave it to 12 for now. However, if we want the rope to look a little bit better, we'll have to change the UV tile length. And because of how long our bridge is, you can obviously experiment with this. I already know that for this length, I'd say maybe let's say something between 200 and 300 will probably be fine. Let's see. Okay, yeah, so this looks fine. We could probably even go a little bit further down. Yeah. Okay. Okay, this is fine. So this looks good. We have a rope here. Now what we need to do is we need to also get the railing that's going to run above this for people to actually be able to balance, hold and balance as they're walking on the bridge. So what we need to do is we'll essentially have to offset up. So we'll get another offset here, plug in this, and we'll say, okay, we want to offset, let's say 3, and let's see, we'll need 2 more sweeps for that, and we'll do a very similar setup. We'll plug in our material again. Okay, and now we have the railing that is going up. Now, this looks all right. However, we do want to make this dynamic. So we want to plug these values in. We don't want to hard code anything here. So let's actually support ropes, and then this would be our railing. So let's start here with our bridge boards, right? So we are currently hard coding that update transform, which is not ideal. We want to plug in the scale here. So we'll get a vector 3 and we'll plug this in. And let me just move these here. I think we're going to need a little bit more space. Okay, so we'll plug in our vector 3 and let's see, we want the width to be we have the bridge width, right? But we want the bridge width probably where the ropes are, and then the bores to extend a little bit more. So we'll say Okay, let's add something to the bridge width, and let's add a random float, and we'll say let's say between 0.5 and 0.7, or maybe even 1, and then we'll plug that into the X. The thickness of the boards we can probably hard code here, and then the board size we can plug in here. Let's say, okay, this is Z, right? Okay. And okay, this is looking back the way we had it before. The only thing here is that the random is not really working. We have to check this per instance setting. Okay, and now we see that every instance of each board is different. I think we probably shrink that a little bit. Maybe something like this. Okay. And you can see here that if we change this now, we'll also change the width of the planks, right? And the board size will also control how big those boards are. All right. Now our ropes are still not using the parameters, so we have to fix that, and we'll go back to where the offsets are, and we get the bridge. We'll get the bridge width here again. Okay, so we're offsetting here on the X for supports. So we'll get the bridge width again. So in this case, we need half because we're offsetting off the middle. So we need to divide the bridge width by 2. And we'll need to plug this into a vector 3 on the X. And then plug this into the offset. And we use the same offset here to both of these. Okay, this is perfect. And over here we have to do a similar setup. So we'll get the bridge width actually in this one. So this, and copy these here. And the only thing is that we also need the height in here. So we have the bridge width divided by 2 going into the X, and then we also need the bridge height going into the Y. Okay, and then we plug this into the offset of the railing. Okay, all right. So at this point, if we change the bridge width, the bridge will just follow. We can change how high it is, and this will still follow, and everything's looking good. All right. Let's move it back to 5 and 2. Okay. And this might be sufficient for a lot of use cases, but we'll push it a little bit further. So a couple of things here. So we want to add vertical supports between the railing and the bottom support. And the way to do that is we'll have this connect point arrays node. And you see what this does in a second, but this essentially creates curves between 2 series of points, 2 arrays of points. So we just need to find the points that we need. So we need the bottom and the top on the right side and the bottom and the top on the left side, and then we'll plug those in. So we need to think about for a second. So we have the bottom and the top, and then on each side we have the original offset points and then the mirrored. So we need to get the original offset points from the bottom and the top, and then we can turn the debug on these, and then we'll see what those look like. And this is exactly what we need. You'll see that also there's quite a lot of control here. There's control for sag, and this can go in both directions. There's a little bit sideways right now. You can also do vertical. So we can do, oh, actually, this is the sideways and this is the vertical. So here we go. However, we can probably do quite less. You can probably do just a little bit, a tiny bit of this, something like this. And this would be fine. Okay. And what we would do now is we'll actually use a sweep node and plug this into the sweep. And we'll grab the curves from our point areas node, and then we'll plug them into the sweep. Obviously, we'll need a material again. Now let's see. Okay. Now, because of how short these are, we don't need the UV tile length to be that high. Let's see. Okay, this is not looking bad. We definitely want to reduce the size of these. Okay, something like this. And we'll have to do the same for the other side. So we can just like copy this. And now we'll plug in our mirrored from the bottom, mirrored from the top. And we should be good. The only thing on this side is that we want to reverse the sag. So it goes in the outside a little bit. Okay. And we're in good shape. And then we can group this and call this railing supports left. And then railing supports right. Okay. Now, what we can do at this point is add a little bit more organic feel to this bridge, because this feels a little too perfect. Now, we can also, in case, let's say you have supports here to hold these railings, right? So let's say you have like another cube here to hold this. So let's say we have I'm just gonna create this. So let's say, oh, that was not, it's pretty far off from where I was hoping it would be. So let's say we have this here, and this is supposed to represent our support columns, right? And we want to extend the ropes to it. What we can do is find where top railing is over here, and we have in the sweep we have extend, and we have extend on both ends. So I can just extend this by 2. I can do this for both sides. and this will extend the sweep. So it'll extrapolate the direction based on the previous few points, and it'll continue in the same direction. So we can do that to kind of extend it a little bit and connect it to any supports that we want. And I can do this for the other side as well. Okay. Now, to continue and add, like I said, a little bit more organic feel to this, we can add a little bit of displacement. And there's multiple ways you can do it. You can do it at different places. So we can add displacement just to the one rope or to the second rope if we want to. That would create a really organic feel. However, the easiest way would be to um, displace the entire series of the sample points, because that would offset everything after that. So we can get that displace points node, and we can plug these. So every place where we're getting these from, we'll just plug those into the displace node, basically plug it in the middle, and we can hit save. And you can see now those ropes have a little bit of noise to them, right? That's probably a little too much and not in the direction we want to. So let's see. Um, let's just exaggerate it a little bit and just see what happens, right? Okay. So now we can see what's going on. So this is going in all kinds of directions, and that's not what we want. So first, we want to change the axis, right? So we want to change this to just in the horizontal plane, because the bridge is likely swaying left and right. Kind of, it's not swaying that much up and down. And so we'll change this to XZ. We're basically excluding the Y and just doing the XZ plane. Okay, we can hit save. Now we can see this is just going left and right, right? And we can change the scale and reduce it to have like much bigger waves. So basically the noise is much much bigger, the scale is lower. This is probably still a little too high, and so we'll reduce the amount. Okay, and we can bump it a little bit. You know, not as realistic, but at least for our purpose here, we can tail a little bit more. And what we can do is we can also bump the stabilize ends to ensure that at the end of the series, so at the end of the curve that we're feeding this, there's less noise. So whatever we're connecting it to, it's not going to be too displaced, right? Because we don't want to create noise right here where our supports are, and then this point ends up being here. Okay, so this is looking pretty good. Okay. Now, this is giving us a pretty good bridge already, but like I said, we can keep pushing it and kind of experiment with different things. So we're currently doing the same sample points for everything. We're sampling the same for the um, boards, for the vertical supports, for everything, right? We're doing the same sample. However, if we want to, we could change that. We could change um, and do separate sample for the different supports, because then we could change, for example, the skip chance. We can say, okay, there's a chance to skip some of those. So we can say, okay, here, let's see, let's increase that a little bit. Okay. Oh, Okay, let's see. Okay, here we go. However, that's not really what we want, right? We don't want the same sample for the boards and for the supports because that kind of looks ridiculous. So we probably want to separate the samples if we want it to look really organic. So we would want to keep the sample for the same sample for the ropes, for the main ropes, but then do different samples for the boards and for the vertical supports. So let's duplicate this. All right. And we'll have the same displays, right? And we'll feed this into our boards. And we're going to change this to gap. And then we're going to increase the skip chance to, let's say, 0.3. Okay. So now this is looking a little bit more interesting, right? Okay. And we can do a similar thing for our vertical supports. So let's see how we did that, right? So we currently have the support for ropes and for railings, and we're connecting this. So instead of using a different sample, we actually have the option of skipping here. So I can say for the support right, I have a skip chance of, let's say, 0.3, and let's say in this one I'll bump it to the same, and then see what happens. Okay, this is good. Now, I could also change this if I want to actually even filter even more. So let's just see first. Let's just see here what we have. So we have one for each point. So if I reduce the skip chance here, we have every one of these, right? And I have the two series, the start and the end points. Now if I want to, so if I want to do that, what I can do is I can get a simple noise, get two of those, and I can, let's see, we have the ones that are currently going into the node that we need. So instead of basically feeding those into the railing supports, I'm going to just first pass them into a node, into a noise, and then let's see what happens here. Okay, so we can see now that some of these are lighter, some of these are darker, right? And we don't want them to be the same, so we can change the seed here. Okay, and let's also change the scale. Okay, all right. So this is looking a little bit more random. Let's even reduce the scale even more. Okay. Cool. So what we can now do is use a filter and filter each of these. And let's say, let's do 0.5 just to see what happens. Okay. So now I can see that all the points that were below 0.5 were filtered out. Okay, now this is going to probably give us like really weird and interesting results. Yeah, because those points are quite off from one another, right? So we probably don't want to filter them in this way. We probably want to use the same or very close noise to both of them. So let's see if we use the same noise. Let's see. Okay. So okay. So instead of doing this, let me actually see if we reverse these. Okay, this is giving us slightly better results, but this is still a little too um, a little too weird, right? So this is giving us kind of a weird mix and match between these. So instead of doing this, we can also do nearest. Okay, and this will make sure that we only connect the ones that are very close. And we can also do nearest unique. Okay. And if we increase the skip chance here, okay, this might not be the result that we want. So let's go back to the nearest. Okay, so this is probably closer to what we want. It does look kind of like a rickety bridge. Okay, nice. And let's do the similar exercise on the other side. So we'll just copy these here, and then we'll plug in the original points from each side into these, and then plug these over here. Change this to the nearest. Okay, so now we have this kind of rickety looking bridge. And then what we can do is we can actually move these boards a little bit up. And I'm going to group this here and call it noise. And let's see, bridge boards. Okay. When we were getting these points here, let's see, we can probably just offset this by a little bit. Let's see. Let's see if this is gonna do what we need. Yeah, this might not work for us. Okay, yep. This is not gonna do what we need, so we're just gonna have to use the update transform and then do it here so we can add a little bit of offset on the Y. So let's see 18. This might be a little too much. Okay, all right, this is looking fine. So I think we're in pretty decent shape here. Obviously, there's quite a lot of different variations and experimentation you can do. The one thing I don't like is that the boards and the ropes are overlapping sometimes. Obviously, they're randomly, we're having a random noise on these. So there's something we can do about this. So what we can do when we're doing the boards is that we can exclude some of the points. So currently when we sample the curve originally, we're selecting from all the points in that curve, right? And what we have to do is essentially exclude any points that we're using for the ropes. So first we need to find all those points, right? So we need to find all those points, and let's see. So if I turn the debug on all of these, okay, this will give us all the points that we're using. And we don't need the, let's see. So we don't need the top, we just need the bottom. So let's see, I think it's these two. Yeah. So we need to get all these points on the bottom and ensure that we don't spawn any boards at those points, right? So let's see. I'm just trying to think here if we should do the because we also have the skip chance here. So let me just see. So okay, so these are all our points if we don't do the skip at that last point. Okay. All right. So in order for me to exclude them, I have to calculate how close they are to the board points. But our board points are actually in the middle. So if we go back here and look at the sample, these are board points. So what we need to do is offset these back. So after we've done all the noise and all that on these points here, we need to offset them back. So let's just start by the one side, right? And we need to offset those points. And we have to use the bridge width, divide by 2. And let's see. Okay, we actually don't want to plug this directly. We want to go here, plug this into the vector 3. And let's see. Okay, so this is in the other direction. So we want this to be -2. Okay, so now we have these points back in here. And essentially we have to do the same for the other ones. So we have to copy all of this, plug in the bridge width, but this time by 2, and then plug in the other bottom over here. And then let's see. Okay, so now they're also in the middle. Okay. And then if we join these, and do the debug in those. Okay. So essentially those are all the points where we have some railing. Okay. All right. And we can use those points to exclude the points that we use for our boards. Okay. So I'm just going to move our bridge boards here. Okay. So we have the sample, and then we're displacing them. And since these points are after displacement, we have to do this after the displacement as well. Okay, so let's see here on our points, and we can do exclude by proximity. Okay, and we have our displaced points for the boards, and then we need to exclude them near those points, and we can say what the minimum distance is. And let's do this. Okay, let's just plug this in here, and we'll see directly what the result is. Okay. So this might be a little too much. So let me reduce the distance to, well, we actually know what that should be, right? So we have the board size, and then we can, I guess, roughly divide it by 2. Okay. And now we have this bridge that it's looking really rickety at this point. I don't know if I want to walk on that, but it is looking pretty organic. We could place more things on it if we wanted to. Like we can place ivy or anything like that. We can, grab any of the points here, apply more noise and filter them and pick, let's say, a certain subset of points and then, instantiate something on them. We could also grab the first and last points here, and these, so over here at the connect point areas, you also have the start and end of the used and the unused points. So you can do that. We could also create something. For example, if there was supposed to be a knot somewhere here, and we wanted to create a knot, we could do that. I can show you how to do that. For example, we can go to instance on points, and we can grab the, let's say, railing support right. We can grab the let me think here. So we did this for the filters, and well, I guess in our case this is going to be a little bit more complicated. But we could grab and invert the filter here and do it this way. But either way, I'm just thinking for all the points here, this is our bottom, I think. Let's see. Yeah, this is our bottom. Okay, so if I grab these and I can join them, So I can grab the bottoms here and join them with the other bottom. Okay, and then plug this in here. And we don't have a prefab. We can use primitive and just create a sphere. Okay, and let's see what happens. Okay, so we're just spawning this, and I can use the same material on this. So I can grab the game objects that we generate from this, plug in the material. Okay, and now I have this really weird bow knot, I guess. Yeah, but you get the idea that we have this pretty flexible bridge that we can now play around with and further expand upon if we wanted to. And it will dynamically follow our curve. We can keep adding more shapes to it if we want to. We could also change the curvature, like the bend on each of these points. So if I enable the advanced mode, I can right click on this anchor and I can actually raise this to change the handle and the curve right here. Okay, so I can make this something a little bit more believable. I don't know if it's more believable, but you know what I mean. And yeah, so this is generally how you can make a bridge, and there's probably 20 different ways you can do it. You don't have to use the sweep. You could potentially just use cylinders or any other objects here and connect them as long as they're fairly small. They'll follow the curve and build a continuous curve and continuous shape with curvature. But the sweep gives you a really organic way to create shapes without having any gaps or having any misalignments because of how big your objects are. But yeah, that's generally it. If you have any questions, feel free to comment. Otherwise, good luck. Thanks.